Good morning or afternoon, depending on where you live. Welcome to Physics 1, Chapter 2. We're going to talk about ideas of force, energy, and work. We'll talk about what is force, balanced forces and unbalanced forces, and how they differ. We'll talk about the idea of work and how physicists define work. They define it differently than other people do. And then we'll talk about energy, because we need energy in order to do work. What's it need to be out of energy? The runner is out of energy. He's used up all of the biochemical energy he has. He's tired. His body doesn't feel like it can move any further, so he's out of energy. The guy in the car is out of energy. Maybe he ran out of gas. Maybe his engine blew up. But in any event, he can't go anywhere either. So being out of energy means that you don't have what is needed in order to make things move. Let's get some definitions. Energy is simply the ability to do work, and we know about that. I don't have the energy to mow the lawn, so I won't mow the lawn. I can't do the work. Work, what happens when a force moves an object? Now, work is going to be a little different for the physicist. We're simply talking about moving something and how much energy it takes in order to make that happen. Force, something that changes the position, shape, or speed of an object. So if we're moving something, we use a force to do that. We change the position, we move it from one side of the room to the other. Maybe we change the shape of something, or we change the speed by making it go faster or slower. Okay, here's some examples of force. We have the space shuttle being launched into outer space. We are changing both position and speed. It started off sitting on the ground and not moving. It's now moving up in the air, and it's moving a lot faster, so we've changed both. Here we have an example of changing shape. The cars are going to be crushed by the crusher up on the top. They're going to be smashed down, and the shape of the car will be changed. Now, balanced forces are those that result in something not going anywhere. In the example that we have here, we have a ball sitting on a shelf. And the ball is pushing down on the table, force of gravity pulling the ball down, but the table is pushing back up on the ball. Now, the two pushes are equal. The ball pushes down with the same amount of force that the table pushes up. So the force is balanced, the object is not moving. Unbalanced forces, one force is greater than another. The forces against an object aren't equal, so one force is more or less than another. Then the object will move. If the greater force keeps acting on the object, it will move faster. An increase in speed is called acceleration. So if I'm pushing on something and I keep pushing on it and I keep going faster, I am accelerating that object. Now you can have the greater force acting on a moving object to slow it down. If I'm pushing on a bicycle and somebody comes up and pushes against me, they slow the bicycle down, and so that force slows things down. That's called deceleration. So acceleration, you're making something go faster. Deceleration, you're making something go slower. Okay, there's our hockey puck. There's balanced forces between the puck and the table surface. The force of the puck pushing down is equal to the force of the table pushing up, so the puck doesn't go anywhere. But if you take that puck and push it with your hand, you start the puck moving. So that is an unbalanced force, and the puck begins to move. The balanced forces, as the puck slides, again, the push down and the push up. And the unbalanced force when the puck hits something, hits the side of the the little table, and it slows down or changes direction, that's another unbalanced force because the puck has moved in a different direction or stopped or slowed down. Work. We talk about work. We think of work as something that you have to do. You got to mow the lawn. You got to do your lessons. Physics people call work simply something being moved a certain distance times the amount of force that's necessary to move that thing. And it doesn't matter whether you move it fast or slow, it's the same thing. It's the result of a force moving an object a certain distance. The two weightlifters here, or this guy on the left with the green weights, isn't getting any work done. He can't lift the weights, so he's using a lot of energy, but nothing's happening. The guy on the right with the gray weights has worked. He has moved the weights from the ground up into the air a certain distance, and he's used a certain amount of force to do that. Now, the gentleman on the left with the green weights may feel he's put out a lot of effort, but the physics people don't call that work yet because he hasn't moved anything. Work involves moving something. Please keep this in mind. This is an important part of the definition. Something has to be moved in order for it to be work. And you need energy to do the work. Things don't move just on their own. Something has to move them, and that requires energy. Weightlifter gets energy from food. He might eat a steak dinner, he might eat a salad, who knows. But he gets energy from food. The food is converted into biochemical energy in the body, and that makes the muscles work so he can lift the weight. The spaceship that we saw gets energy from rocket fuel. The rocket fuel is burned, and the chemical reactions cause the rocket to go into outer space. And we'll talk about different kinds of energy in later chapters, as we have more than one kind of energy, and energy is converted from one form to another. So we'll talk a lot about energy later. So where have we been? We talked about force. We talked about the ability to make something move. We talked about balanced forces, and when balanced forces exist, the object is stationary. It's not moving because the forces on it balance each other out and it can't go anywhere. An unbalanced force, one force is greater or lesser than another force, and then that will make something move. Work is about moving things, how far you move it, and what kind of energy you need to do this. The energy is what allows us to do work, whether it's biochemical energy in our bodies, or whether it's gasoline in the car engine, or whether it's a rocket ship burning fuel. That's energy, and that makes things move. So that's it. Thanks for showing up.